So, good afternoon, everybody. Let's start this parallel session hosted by the Italian Planning Association. And let me thanks the organizer for this opportunity. And so thanks to COB and to this conference Beyond the Tunnel Vision for the second European Conference of Tunnel Renovation, on Tunnel Renovation. I think that this is a very important topic, as we had also debated during the open session, and this is an issue for especially for European countries that has a great numbers of tunnels in operation that are quite old. So thanks for this opportunity, and let me introduce myself. I'm Andrea Pigorini, president of the Italian Tunneling Association and responsible of engineering department at engineering infrastructure department at Italfer, that is the engineering company of the Italian State Railway. And we will have this session that will deal on inspection, investigation, and monitoring during tunneling service lives. And because of the importance of the subject of the arguments, we have dealt with these arguments also in Bologna during a conference of the hosted by the Italian Tunneling Association last October. And so what I want to do in this session, basically try to make a recap, an international recap, let's say, for all the listeners. So to give you, let's say, the kind of overview of what we have debated and discussed in 2 days conference in Bologna last October. So I asked Professor Salvatore Miliziano from University of Rome, that will be the second speaker of this session, to talk about damages on lining induced by construction of a new tunnel and the design of refurbishment, and he will show us a case history. Sometimes we need to upgrade our tunnels, and we upgraded it by doubling the tunnel, and of course you have to pay big attention when you are excavating a tunnel just aside of an existing one, especially if it's old and have some problems. The third lecturer will be Professor Giampiero Russo from Naples University, and we talk about inspection and monitoring for tunnel maintenance, analysis and experimental data. And basically he will show us the modern technique of inspection and monitoring, like laser scanner, LIDAR, digital image, and georadar, thermography. Well, a lot of methods, and they will show us, let's say, good things, and also, of course, how much we can rely on these results. And the fourth lecturer is Professor Paolo Mazzanti from Lyon University, Structural and Geotechnical Monitoring for Infrastructural Asset Management, New Perspective. So his presentation will be especially about Earth observation satellites, the technique, and in particular the interferometry, satellite interferometry, that is a technical that is very well known and very used, especially, of course, at the portion of our planet. So I will start my presentation, and that I share with Marco Ranieri, senior manager at PricewaterhouseCooper, where we are having this session. So I thanks Marco, and thanks also PricewaterhouseCooper for hosting this session of conference. So I want to start with my presentation. And okay, what do we need to prevent problems during tunnel operation? I wanted to start with these two pictures now that give you big problems, of course, like the egress of ground from a sidewall of a tunnel, from a niche. This was a niche on a railway tunnel that was in operation, or this big void that sometimes we can find above tunnel crown, above, let's say, the pre-line, no? And of course they are very dangerous because the rock can collapse, and these have been found during inspection because there was some problems, and you can see the curve below. So I mean, this can be problems, and of course in Italy we have to deal with these problems because we have a lot of tunnels. No, tunnels in Italy. It's very important because of the country. More than 66% of our surface that is basically hilly or with mountains. And so that's why we got a great number of tunnels, more than 2,200 kilometers of tunnels, road and railway. Coming to the railway, it's about 1,500 kilometers. And of course, we have started to dig tunnels, to excavate tunnels since ancient Roman time, and sometimes they're still used today as road tunnel. But coming to the, let's say, to the industrialization of the tunnel industry, we can probably fix it during the construction of the Frejus railway tunnel in 1871, where also the first compressed electric machine were used, the father of modern jump. And then going on in the years, we excavated a lot of tunnels using the sequential excavation method. What was with multi-drift tunnels excavation using woods for prelining and masonry and bricks for final lining. So coming to the railway tunnel, we can again give you this figure. Basically, let's say around 30% of our tunnel had the lining made by concrete, recasted or reinforced or not reinforced, and more than 60% of our tunnel railway tunnel are the lining made by bricks and stone masonry. So, coming to a tunnel life cycle, let's say, assessment, we have the new construction. Then of course you have to have maintenance. Minor works needed to guarantee tunnel design service life, like for instance dealing with water problems, waterproofing problems. Rehabilitation, when you have bigger problems, such as tunnel inverlifting. So in this case, you need important structural rehabilitation works. Then upgrading of the tunnel, when sometimes you have to double it or to reshape it, to enlarge it. To host a bigger gauge or to host one more lines, one more tracks in your tunnel. And then, of course, disposal or probably better reuse of the tunnel for different purposes. And we have experienced in the Italian State Railway a mobile diagnostic system that can scan and map thousands of square meters of linings very quickly, and so to have a report and data analysis and evaluate the damage of the tunnels, and then of course define priority for this refurbishment works. We have experienced a different vehicle, and then we came up with this two-mode hybrid vehicle that can go up to 30 kilometers per hour, so quite fast, and scanning with high resolution, mapping all the surface of the lining. Then, of course, we need and we have post-processing software that can detach lining damages and wet portion of the lining, and of course, these tools are very friendly also with virtual reality tools. I won't show the movie for times, but of course, you probably know you can inspect your model with virtual inspection, basically after you have scanned your tunnel surface. And we have with the Trento University, we have improved the validated algorithm to evaluate the tunnel lining damages from data acquired through a mobile diagnostic system. We divide the tunnel in stretches. We classify the damages. Then, of course, you can evaluate the damage severity, you give an index, and then, of course, also the damage diffusion. And then, of course, you can basically define a priority for maintenance and rehabilitation works. And now coming to some kind of works, maintenance works, let's say the easier one, you scan your surface of the tunnel, you double check, of course, on film. Then you probably will design contact grouting, cracks repairing, drainage and waterproofing with sprayable membrane, second line of shock. These are, let's say, important works, but also, let's say, minor works for maintenance. When you go to structural strengthening and waterproofing tunnels, probably you have to have bigger works, like always dealing with the injection, because as you can see also in this picture, often you have this void at the back of the old lining, and you need to fill it up with mortar. And sometimes you need to have an invert or a slab to close it, the tunnel also in the invert. And sometimes the invert you can have it in the old tunnel, but it's as a bad shape, let's say a banana shape invert with a very little thickness in a critical point where the invert goes in the sidewalls. And this can can cracks, can break, and in some cases you have to rebuild the tunnel invert, like also with artificial ground freezing, if your tunnel is in a ground, permeability ground with water bearing. When go to upgrading works, of course, to large tunnels, probably if you outside of operation, it's easy. You just is a normal tunnel, let's say, you demolish the tunnel while you're constructing the new one. But in some cases, we have been able also to enlarge the tunnel during leaving the operation underneath it. So basically, we got the protection shields, the whole tunnel lining that is going to be demolished, and then the enlargement surface and the new tunnel lining. And this has been done in a couple of cases of projects in Italy, in always on the highway, in Azzano and Montedomini tunnels. And I want to show you, if Pablo helps me, a little video that probably give you the idea of better than my words. So you've got a pre-cutting machine with this big saw. The old tunnel, and then
the excavation work to expand the tunnel is carried out using the pre-cut technique, which enables a protective structure to be created before excavation takes place. The earth around the tunnel to be excavated is cut away with a 6-meter long and 50 centimeter thick blade. This cavity is then filled with sprayed concrete, reinforced with steel fibers. A concrete shell is thereby obtained that allows the excavation to proceed in safety. The cutting blade is guided by a special machine that enables it to be precisely directed along a predefined arc. Once the protective concrete shell has been completed, the excavation continues with conventional methods using excavators. In the wake of the excavation, at a distance that never exceeds 6 meters, the tunnel's final lining is carried out through the installation of prefabricated segments. This is achieved using another specialist piece of machinery developed for the project that enables the segments of the lining to be handled and installed in safety.
Important method to enlarge tunnel under operation, especially road tunnels. Well, better disposal, better clever using. You can use your tunnel often for cycle. So or this big cavity, you use for underground car park. So this is a nice disposal. So let's come to the intermediate remarks and then leave the words to Marco Ranieri. Tunnels are released infrastructure, and usually their service life is much higher than their design nominal life. This has increased the number of existing tunnels in operation with an average service life of more than 50 years. Recent cases of tunnel lining local collapse have highlighted the necessity that future investment in underground infrastructure have also to foresee maintenance, refurbishment, and upgrading of works of the existing ones. New technology can help to manage the entire life cycle of tunnels by using large-scale monitoring, automatic process of tunnel line scanning to realize the tunnel digital twin, to which apply algorithms to detect lining structural problems and damages. When dealing with existing tunnel, geological and geotechnical models are similarly important to understand the causes of detected problems. The industrialization of rehabilitation work is an issue still to be improved. Okay, Marco, thank you, and I leave to Marco Ranieri.
Hi, good afternoon. I'm going to talk to you about engineering construction in a post-COVID world, and I'm going to focus on the Italian market and that we currently have about maintenance, investment, and potential of the new technologies. As you know, in Italy, but around all the world, we have a high economic slowdown caused by the COVID-19. We have a GDP reduction in 2020, estimated about 12%. We have a strong uncertainty about the economic recovery. And this tragedy represents, in a way, also an opportunity that can restart from the infrastructure sector and from the priority of what Italy have as infrastructure investment. The engineering construction sector industry is worth about 77% of the Italian GDP. And currently, we think that the launch of a major infrastructure investment program is the key intervention to counter the strong reduction in economy and drive the recovery phase. It means that main contractors, subcontractor, client, authorities, all the financial system and the government have to work together to give a contribution to the implementation of such program, aiming to a sustainable development in a long term, a value creation on the territory, and starting from the maintenance of the asset that we have on our ground. This slide summarizes the main numbers, the main elements of what engineering construction in Italy represented and of some of the main issues of such sector. As we can see, there are some major problems, major issues, the time, the average duration of the major projects, the amount, the extensive amount of the contracting authorities, the fact that Italy currently is at the 24th place in Europe in spending money and public resources from EU, and the cutting of expenditure in the sector in the last 10 but probably 20 years caused the main contractor going abroad, risking themselves, losing employees, and now the situation represents an opportunity for this reason, because the internal market can boost the such industry recovery. We identified 4 main areas, as you can see in this slide. The first one, that is define an investment priority, a list of projects, and unlocking both the public and the private money. The second one, that is rebuild the key sector, the engineering construction sector overall, with new, resilient, stronger, bigger players. And the third one, that is about the projects. So we have to think circular and think sustainable project along the entire life cycle. The fourth is regarding what we are talking about today, and is unlocking the potential, in particular regarding maintenance and repair of the asset. Here we can find the 4 areas of priority of the EU funds. As you can see, the first and the third are probably the more critical for Italy now. After the collapse of Ponte Morandi, in fact, we have to concentrate our effort on a major maintenance program. As we're going to see in the next slide, we have an overall age of our important asset on the both rail and roads network that is more than 40 years old, and that means that we have to invest in maintenance. On the other side, we have a territory, we have a ground with a hydrogeological risk that have to be mitigated. So we have to plan the intervention, we have to put money on it, we have to program all the project to solve such important issue. This is what I was talking about. We have an extensive road network, and apart from it, we have a number of main structural works, more than 30,000, with half of them with an age of more than 40 years. It means that the effort can't be only of new projects, but have to be concentrated on maintenance and operation, inspection of such assets. So here we have the value of the infrastructure maintenance. We know today that the approach to the maintenance is different from what it was in the past. We talk about predictive maintenance. We have to put into in all our planning phase and strategy the plan for maintenance of the asset. And we know that the literal data show that the lack of ordinary maintenance produce a reduction in the useful life of about 50%, with a consequent increase in the maintenance cost. That means that planning intervention of maintenance in a predictive way, using also technology for inspection and from maintenance works, can also reduce, optimize cost for the concessionaire or for the company that is going to manage then the asset. Here we have how the maintenance and repair strategy and cost are today counted in the financial model. The financing model, obviously, the financing model are currently highly dependent from the values and the cycles of maintenance and repair. However, in the most cases, this is an important point, but on the other side, in the most cases, typically we use two kinds of estimating approach that are quite superficial. In fact, we usually use benchmarking on data from engineering design studies, considering the maintenance of the assets as an overall number. Now, because of the complexity of it, more in-depth analysis would be required for complex infrastructure, such tunnels are, considering the specific maintenance and repair needs of the different subsystems that compose the tunnels. And we need to optimize the financial profile of the project along the entire life cycle. So the lesson learned of it is that the new modern infrastructure tends to have lower maintenance costs in the first operating period, and that tunnels as a critical infrastructure need to have an approach that goes more in deep to analyze which the maintenance and repair costs are and how they are split between the subsystems. Talking the potential of technology, as I was talking before, technology today, that means all the type of tech and automation system can really get and cause a boost of productivity of a sector that, as we can see in the graph on the left of this slide, didn't grow along the last 20 years. There are other sectors that grow steeply, and construction, one of the reasons why construction didn't get this was because we didn't include or we didn't use technology as we are going to do now and in the next future. So technology is the really enabler of it. Here you can see that the technology are going to impact the entire life cycle of the project. Now we are going to concentrate of the asset development and maintenance phase, but there are different type of technologies, different type of instruments that are going to have an impact of it. And we have to introduce it not only to have a cost efficiency, but also to increase the safety standard of the asset. So in conclusion, there are several technologies. We are going to see some of them with the presentation of Professor Miliziano and Professor Mazzanti about automation and monitoring control. In the automation, as we can see, we have digital mapping, for example, of pavement degradation condition, immersive digital inspection for tunnels, but not only for tunnels. And monitoring control, we have the artificial intelligence, the control from satellite, and for example, the digital twin augmented reality for inspection. It means that we are going to have a different layer of instruments that would allow us to control and inspect the asset also from remote. Thank you very much.